So, so the benefits of thinking about this are obviously this atomic data set is this idea that, well, we could allow people to decide how to publish data. This is certainly possible today, but we have an authoring tool. Most implementations of IFC write them to a step physical file. That's either a one-to-one or very similar to a one-to-one nature, but we have no way to assemble this data into pieces, package it. So there's a decision-making process that could sort of be versioned. So this idea here is, if you want to enable these object-based workflows, these are the sort of things you want to think about. But again, we come back to this notion that if we only solve for individual objects, we haven't solved the distributed ownership problem. But we know distributed ownership in these, at this point in time, is not just IFC data, it's infrastructure, it's all kinds of pieces of information that, you know, might be buildingSMART standards, might be maintained by OGC. So generally this idea that we need to sort of plan for a multi-standard implementation as in IFC is not the only piece of data that we're actually trying to link together. So this is a departure from the previous approach, which would have been to align the models, the sort of definitions as much as possible, and then convert, right? This is what we're talking about today is a departure of this idea is actually I have a certain data set here and a certain data set there, and I actually want to relate them to one another, but I don't want to convert them because this is a meaningful topic. And so that's the second thing. And this is sort of where you get this, and some people like to call these digital threads or something like that. How can we relate all this data together without having to convert to a sort of huge master format? So I'll just play through these slides quickly. But what you end up with is, okay, we have IFC today. We could break it into individual pieces, but those individual pieces aren't enough because we need different representations that buildingSMART doesn't necessarily provide. I'll skip through these. Sorry, tend to do animations. When looking at them, they're not nearly as complex. So the approach you could think about is say, okay, IFC is going to be the solution to all these things. Good, Jeff? Okay. IFC is going to be the solutions of all these things. But at the end of the day, ownership of this entire concept of a distributed built environment, it has to be much more diverse, and it can't be sort of one standard to rule them all. So we end up with a sort of a need to sort of make a bridge between what we have in IFC today and what we have in these other formats. And I'm just listing some that have come up. There's hundreds more that aren't described in the Rail world. There's others that aren't represented here. The point is we should plan for anything to be related to a future version of IFC and make that simple, not something IFC and buildingSMART has to necessarily design for. So questions so far? This is just background information, I suppose. Okay, so we had to give it a name. This is not a name this buildingSMART will care about in the long term, but to differentiate things when talking about that this isn't IFC that the things get put on top of, we'll call it a protocol, it'll get a number, all these things, but for time being, it's easy to give it a weird name so people remember it's different. So this strange matter thing is the piece between, and I've talked to more than people than just buildingSMART, so the name is hung around for a bit, but again, it's not the important part. It's really just a protocol of how to put this data together. So really what we're trying to do here is not just modernize IFC, because we could do that in a vacuum. We could make it object-based, we could make it work on the web, those sort of things. But the main requirement is we have to live in this distributed ecosystem. And when you look around, no one has made the thing to make it distributed. And so the key place you could look is what the web did, sort of this layer stack approach. And so really what we're saying is, I'll go one more ahead here, that if we adopt a way to, independent of serialization, independent of schema, capture definitions in an entity component, system. We'll talk about what that means in a second. Then really what we're sort of making is the equivalent of transport. So how do you put these pieces of information together? But I don't really care what's inside of it. We will care in the Building Smart context, but this is the sort of approach you have to take if you, by separating the concerns, it allows us to decide, Building Smart is going to put our standards in here. And so really what you end up doing is, we don't use the word entity component system a lot, but this is definitely where it gets its roots. A lot of the major software vendors are exploring this because they have the same problem internally, mini formats, but I need to pool this disparate data together. So you won't see ECS. That's the acronym if you're looking around for the inspirational ideas, but it's really the notion that you take an object and you break it into an entity. Entity is just ID. Components are chunks of data, and the system, so ECS is the acronym you see out in the world. System is really the sort of computational side of keeping things up to date, mutating the data. When adopting a sort of software approach to data, really we really need the entity and component. Okay, so the key thing about entity here is it's just a UUID or a GUID. It doesn't hold any data about it, about what it defines. It doesn't, describe anything. And the key thing, based on some of the other requirements, is there are some systems where the entity understands and knows all of its components. That would work if you had a centralized system. If you need a decentralized system, you have to do it the other way around, where all the components know about their entity. So entity is really the thing. A column is an entity. Floors, walls, ceilings, alignment, anything you can put a sort of a box around and call it a concept. I mean, in the building space, we have spaces, which is not really a thing. It's just a collection of, virtual things. That's an entity. Questions on this thus far?
First of all, thank you for this amazing introduction. So I just want to mention, I guess we will cover this, but one of the biggest challenges is the maintenance of goods in all updates and so on. So from the side of the authoring tools and how we use this. So this is so my question is maybe you have included this in the rest of the presentation, but how to maintain proper GUID, especially in infrastructure.
So we'll talk about some of the things that it presupposes. I don't know if I have exactly the answer we're looking for. So the couple things just to talk through the assumptions, I suppose. So the entity is actually virtual, which is, there's probably a better way of saying this. Somebody with a computer science degree can give me the better way of saying this, but you actually don't need the entity to be manifest here. It's actually just drawn so you can understand it. So the first component that makes data actually establishes the entity. We have put out there that we might want a standard component called an ID component that says, I'm first, I'm username, I'm whatever random information wants to be carried around that's not well defined, and that wants to establish the component. The other assumption and thing we've talked about is that, well, these, in most cases, especially if we're doing sort of cross, let's call it entity traversal, is these want to be immutable. So they very much want to be versioned, not replaced. There's certainly a place for where you could mutate them, but they don't want to be something, especially if you're a cross relationship, if you don't own the component. This is a very much, Building Smart is not in the position of making an ownership-based technology, but this is clearly set up so there can be owners of components, right? So if you don't own information and aren't in a position to mutate it, you should not be doing such. You should actually make a new version of that component. Doesn't really address this IDs are hard to maintain question, The one thing nice about this is if you have one component, you know all the entity, right? So if someone deletes a component that they gave you, like, oh, this one disappeared, you still have the components that you might have created describing that entity. It doesn't perfectly solve this problem. We could go down the path of an entity service or something like this. It's not the place we're starting, but it's certainly something that's considered here, that by breaking this up, you can make it distributed ownership and data destruction much less of a big deal, because you don't lose, on an update, you don't lose data you've created on that entity. Any other questions? Russell?
The components, if I take the example of a column, a component may be a bar.
Yeah.
And so will the components also have IDs?
So every component has its own ID. Yeah. Yeah. And it's got a third if we talk about versioning. So every component will carry around an entity ID, a component ID, and version ID.
So thanks for the presentation. Maybe you are going to cover this later. Are we thinking about a reference list for the entities, or how are we going, or for components, and how can we make sure that components are not overlapping or conflicting?
Yeah, so this is where this is where the S comes in, that, buildingSMART is not a service provider in this context, but so if you look at what's happened in this USD space, is forgive me if not everybody's aware, but in the VFX and film world, Pixar developed the standard called USD, which basically says we're going to externalize all the data outside of applications. And they did two things, not just one. They made a format and a library that maintains that consistency. But they are more than happy to live with duplicate data outside of an application, because you're given a choice, end user software developer, to determine what's controlling and what is not controlling. So we don't have any mechanisms to maintain consistency, but we do have all the mechanisms to know something is inconsistent, with version GUIDs and these sort of things. So like a service that would ensure that something derived along an alignment is consistent, not something buildingSMART would build, but can you, from the data that is there, understand that relationship? Yeah. So, well, what should be apparent here is anyone could add a component and it doesn't have to come from the same author. Once that's the case, absolutely you have a different problem of consistency, but it's you trade some problems for others.
Thank you for the interesting starting. So I'm still trying to understand this, the boundary between the object and component. Maybe I can explain component like a cluster of objects that could be treated as a component. And we go further. Yeah.
Well, I'll just be clear. You don't want to think about it that way. You want to think about every component is a sub part of a single object. The other way. So like Rosso asked the question like about rebar. So this column presumably has concrete and rebar, right? The finish, one component. The concrete, one component. If there's a piece of steel in the center, one component. If there's rebar, one component. And if there's a couple property sets, fire rating, installation date, time, sequence, all of those are individual components. They all together describe the entity.
If we have a concept like larger component, so we have boundary, substructure, and define it as
well, so you're basically describing things we do in IFC today with relationships, like assemblies and these sort of things, which is where we'll describe how relationships are used to sort of collect them together. I'll be clear. This system would allow you to put a whole IFC file in one component and call it an entity. I mean, there's nothing keeping you from doing such a thing. I think the reason to go this direction is that you make the smallest logical data sets, and that is a flexible term. It's not a fixed term. So in one context, the data might be this big to describe that column because it's simpler, or it want to be broken into pieces. We're not really, no one is proposing applying governance to this at this point, to say this is the way you have to do it. But we will have a way of making relationships that says these 10 things together make an assembly or something like this. Yep.
Yeah, I'm still not clear about those components and the entity ID. Do they share the entity ID, or each component has that?
So yeah, so every component will share or have its shared entity ID. So every one of those things I described in the column would describe a singular entity and have a singular entity ID. They each themselves has a component ID. They're like sub-objects. You have to think of it sort of that way. So I need to know my parent object ID, that's the entity, and then the component ID, and then the last one is a version ID. But at that level, every one of those data sets would look exactly the same. They would all have all three.
So you will get rid of shape representations, like for multiple geometries. They'll all become components.
Yep, and each one of those representations would have its own component ID, but making it much more flexible to have multiple, and two parties could own different representations.
The version, would it be if you would say, okay, the columns now would be blue? First it was black, and then it's blue, so the whole code will then change to a version 2, or something like that.
Well, so we haven't, certainly the only thing that we've stipulated in the way we've written it up thus far is let's say it's the material component. It says that's blue, or the paint component. We have to pick one. That's the only one that would have versioned, right? Because if you think about it, if you break this example on the screen in half and imagine that one side is a contractor and the other is a engineer, they don't have to know about each other intentionally, right? And so the idea that you could version the whole thing is not really theoretical possible because you don't know of a change.
There does need to be some sort of constant of time that you need to know that version 2 of component 1 corresponds in time to version 3 of component 5.
Right. So we've thus far, so the Angel is basically saying you need to have a correspondence. Thus far, we've said, and we'll get to it in a second here, but we do need a replacement for files, which is some sort of boundary that collects versioned states of components to say, oh, these go together, right? You can't just exchange components. Otherwise, we couldn't do any workflow transactions and stuff. We do need something that sort of, it's called a collection, collects up the components at their versions and says, well, this is the group of things I care about at a time, and I can make a transaction if I want to sort of send you a lot of components at the same time. We haven't considered you might call it a state concept of a whole component. It is sort of difficult to think about if you don't have all the components.
My understanding is that these entities are also independent. Like, from each other. I mean, what is the question about all the interdependencies of the components we share among entities? Like, I don't know, having the same position, utilizing the same shape.
Oh, okay. So we definitely have, like, this is where we still, like we do in IFC today, we'll use the relationships. We just have a little bit more flexibility. You do types of relationships. Everything is a relationship in this sort of world. We'll get there. Okay, so let's talk about what a component actually is. This is just basically saying you have a header that says what I am. Each one of these components, and that's a relationship or an individual component, basically has to be self-describing in some respect. What I am, version, what entity I describe, who made me, where did I come from, where am I stored, what's my definition? You sort of have to make them very well described, because in a lot of workflows, the first version could be, I'm just sharing one, right? The whole point of a system like this is you don't have to say, I have 1,000 pieces of data that describes this column. I only need to share one of them. 100 of them you'll never see, and eventually you'll get the others. I'm not saying this is it's just a transactional based workflow assumes you're not going to share everything all the time. And so basically the header is doing all the heavy lifting of linking the component back to the equivalent of BSDD, like that part of the conversation. Where did I come from? And then describing, well, where did the instance data come from? If that makes sense. So that's like BSDD plus the file header of an IFC file today, roughly.
It's a very interesting slide. So just one question. IFC, we have geometry, a lot of things, but let's say geometry and have also properties. So I was wondering if you go back to this, could it be that component instance also are the properties? And because then when you mentioned this, the idea is just a use case. I just add one property, single element in a huge IFC file. I really don't want to publish that file again. So just to differentiate geometry from the property side, because also statistically they will change slightly more data properties than geometry, hopefully, but it depends really on the workflows and each use case is specific. But could it be that this is also a separate set of components, like what we said, property sets or so directly in hardcore the IFC?
So absolutely, the most logical separation is you separate geometry in its own component entirely. This is, I mean, there's some reason you might want to do like derived attributes as part of the same component. There's some logic could be said about that, but absolutely, like component number 6 there wants to be the geometry. Component number 5 wants to be the QTO or the quantity data. You know, component number 4 wants to be fire rating. That's the most, like, when we say logical. This is, so one of the things that, if you've been around long enough, we looked at sort of the linked data approach to this, which is a graph and triple stores. And one of the challenges with that is the data is, you either go from a singular file to you have to care about every edge, which is every relationship between a property and object. But in our world, people can logically describe what are the chunks of data. Geometry is one, a set of properties is one. The smallest component is one property, logically, and like a textual property, string 1, right? That would be a logical smallest component, but they vary, right? And the point is not to set the size, but to make it so you can logically define how you would like to structure the data. And that's why sort of this system is an interesting middle ground. This will work in a sort of triple store. It's just that the objects are a higher level, but they're not full objects. Russell.
Component 6 could be level 1 geometry. Component 7 could be level 2 geometry. As well.
Probably not. You'd probably actually want to make those, well, I'm trying to think if there's some object that actually thinks that way. An elevator, you'd probably actually make those separate. Well, if it's the same geometry, you'd have, okay, so LOD, absolutely. I mean, these are all, yeah. The one thing you probably don't want to do here is think about, and this is where we will get to, we haven't made any hard and fast rules, but we are probably removing the inverse relationship so that number 6 doesn't know what level it's on. Its level comes from a relationship. And so the geometry, if it's shared or these sort of things, would go for that way too. Okay, we'll get going. It should not be lost on everybody that actually all our standards fit really well inside of this. Not only should a issue on an object be able to be put inside of a component, so I can make one object that has its geometry, its requirement as a component, and an issue. So this is a sort of, it's intentionally multi-standard, and we have 3 standards that fit in this category. So you should be able to describe and include the requirements on an element along with its instance data. So let's talk about how we assume this is going to have to work. So if you imagine what we have in BSDD today is object definitions, we have classifications, most of which are object classifications. Really what we're saying is if we make component definitions, this allows for internationalized component definitions. PSET wall fire rating properties is a logical component. But we heard, like in Zurich, when we started doing these presentations as any component system, that they use everything about IFC, but they use a separate classification system to describe the componentry. So a localized component that says, I have a set of properties, I have a set of name, but I want the IFC geometry and these existing properties. So what this is surmising is definition becomes distributed, but you need some tooling, and we have to think ahead of this so it doesn't get out of hand, because this is the inverse of the inverse problem we have is we have singular definitions. We're breaking into smaller pieces. We need to allow other things. So the terminology that you get from this space is an archetype. So the idea that what I've done here is I have standard 1, BSDD, my internal thing, 2, whatever. You put those together and you define a set of archetypes. So archetype is really just all the components that describe the object. And not all of these components are single standards. That's sort of the point. Like a picture, carbon, matrix instance data, spatial data, certifications, all this stuff is just random examples of things certain entities and workflows would want to associate with a project, a country, a requirement. So you need some way to wrap these up. And so archetype was the terminology where you say, well, actually, this collection of component definitions is what I need to do my work. Doesn't imply that one entity has to do any one of them, or one software has to create any one of them. Questions? I will skip this slide. Just go through these quick. Interest of time, we'll keep going. So let's take this archetype, and it's always good to start with a simple example. We'll go to complex ones. So let's say we have this archetype, and I have a piece of software that makes three of these entities, or excuse me, 3 of these component definitions. So it places the chairs. It's the simplest furniture layout software someone can make. Version 1 is what this is called. So this is basically surmising that the first thing we'd probably make is the ID component. I always forget I have this one section out of order, and I forgot to update it. So skip here. So basically the workflow will look something like this. So the first thing that gets written out of this application is the entity. Now there's the debate. Do we have a ID component? What I'm showing here is just the 3 pieces of information that we said we were needing from this application. So a style, a location, a geometry. Geometry is dashed because it's just in the workflow diagram, it's indicating that this might not be the one we actually care about, but I can get it from this application. Location separate from the geometry is important though. That's its position is independent of the geometry. So the way to, and I skipped over this, but it's an important thing that we've been talking about in our community for a long time, is a notion of how this can enable design transfer. And so the key thing here is by breaking these data pieces into chunks and pushing towards a reference workflow, we actually fully support not transforming data, but just having the data that existed prior to being moved into an application actually existing after it moved out of an application. So you can do something which is like design transfer, but you don't have to have perfect interoperability on geometry. So the point is, if we take the application one, publish some components, reference those components into the second application, I can copy, create, or map, as in make some new data inside of the existing application. Leif Grunholm has always pointed out that Tekla, when it always references an IFC, it actually brings in an IFC, and then the second you want to make a change, it duplicates it, and now you're editing a detached or a referenced copy, but it is a copy. It's not, you're not editing the native data. So by embracing this fact, you can add the new information, and because the combination of these things can happen external to the application, you get to do something where you choose which one of those you would collect up and move forward. So I'm not destroying data if I move it through an application, because I still have it. I'm just adding to it and versioning that data as you sort of add more applications to the chain. So because this plays forward logically to say, if I have a sort of contractual relationship, there's a procurement step, I can share a couple of pieces of information. The company on the other side of this relationship can add new data. And the point is, the white boxes came from the left side, but the right side can add new data. And then if this were to be updated or iterated on, sorry, I forgot I took that slide out, updated or iterated on, like if locations changed on the left, they could be updated on the right via a new version. And basically any of the data that existed that was added out of sequence, so you can think about this as sort of it breaks linear data requirements. They can be updated after the fact. And this could be version 2 on locations that came from the design team, but the data that was added on the right side, just fine.
Again, now this is an excellent example why I asked about GUIs. So let's say I'm an architect who designing Revit, and it creates a GUI. Okay, and until this element is destroyed, it will remain. But let's say I somehow, by mistake, deleted those elements, added the same chair again. The guy on the right-hand side lost the connection. So this cost, procurement, and so on, connection to that chair is completely lost. So just want to emphasize that we should talk with all guys who maintain the authoring tools and develop authoring tools to find some way how this. There is an idea maybe to have some specific certain features or properties of certain elements which will be recognized that this is the same or something like that, but it's not easy task. So we did this in infrastructure, so same change, same profile, even if you remove it and add it again, the system will recognize that's again the same, but it's very difficult. That's why I'm asking about ID, because if I understood correctly, it's one of the cores of the new system.
Yeah, so just to answer the question here, certainly because we're not trying to make any tooling, but we're assuming we have to make the data as rich as possible to support that. So one of the assumptions is like, we're not providing a mechanism to find the same object, but two things are true. One is it could be, and these are not rules yet. So one is, if I delete something, actually what I do is I transmit the object, but I deprecate it, right? So I'm not actually removing it from the data set, but I version it. And so version 1, I created it. Version 2, I updated. Version 3, I deprecated. So that's a delete has to result in a deprecation. It doesn't result in a, sort of, it just doesn't exist anymore. So that's one. But also by breaking these into smaller pieces and having well-defined components, you could imagine like making something that makes it easy to determine, are these the same objects based on location, becomes really straightforward, or much more straightforward than it is today. So by making the data sets more granular, we think this is helpful. It wouldn't solve everything. question here.
In this workflow, if I understand correctly, in the end you could get with everything different other than the shared entity. So the location, geometry, every part of every component can change until the end of the project, basically.
Yeah, I mean we're not in a how you run your business organization. We're how the data should work so you can use it flexibly organization, right? Like we're not in the governance. Like you have to not delete your data. Not our job. Should the data be flexible enough so if you do have to mutate it, it's clean and understandable? Absolutely. One in the back.
Would we say rather it is a private thing? So every tool can define their own components. There's no need to standardize components.
I don't think buildingSMART is going to embrace this view of the world, just be clear. But all the private versions of these systems inside private companies, like major software tooling, they're absolutely thinking that, oh, I can have binary components that only one tool understands. I just don't share them. They're not shareable. They don't move outside my organization. So the protocol itself is flexible enough to allow that, but we wouldn't have a buildingSMART ordained exchange that used any of that data. But absolutely, you could have private components.
From a game development perspective, this looks a lot like asset pipeline production.
I'm showing you an example because examples, we're making these changes to facilitate them. This is just a dumb, simple one. Yeah, like this does make tooling much simpler to imagine. The next actual slide I had is this is Tom Van Dieg, who's the CTO of BIM Collab, doing an example of what you're just describing. So this is a server-based entity component system that's inspired by the work we're doing. This is a prototype he's working on. So this is live transactions. So like, again, we're not going to be in the tool building industry, but we need to support, slow, laborious, you're going to get updates in 6 months, or we have a way to, once you have a connection on either side of like this component and its location and you can mutate it, then that's an example. So this is really just using the exact same thing. So actually, I think I brought it in here. So these are the 4 components he's described based on what we have in IFC today, but he's simplified them to do this demo. But yeah, I think we can all imagine how you could make tooling and pipelines and all kinds of things make this very slow file-based transactions where I have to do approvals. You could break this into sort of much more robust pipeline sort of things. It's in the thinking of how the data should be described, but not the tooling we make within buildingSMART.
Yeah. But the data structure you are showing us will probably improve the project performance, but a lot of data is already existing from objects and components. How do you get this into your new structure?
So the 2 paths we're going to get started on, like this is sort of the kickoff to this effort, is to take existing IFC data. Actually, Thomas asked, we're going to be in the meeting tomorrow, because is forward-based compatibility the right choice? Backward is harder than forward, but forward is certainly planned for. And the components, the relationships are a real key part of that. So we certainly know we have to bring old data or other current and which hopefully will be old data in the future forward. Backward is there's a lot of things we'd have to do that don't necessarily make a whole lot of sense. So, but that's certainly the point.
You can see the workflow. Yeah, this one. And during this workflow, the entity and ID is it. We have to use the entity ID to control the workflow to let everybody can recognize the object.
Yep.
So my question is, if the ID is fixed enough, for everybody. You know, if everybody have to recognize by the entity ID, so that means this ID have to be used for everybody. And we can regard the topic downstairs, the digital product passport. Maybe they are talking about some very essential data about the project. Is there any relationship between this ID and the passport, some metadata?
So Lars, help me with Lars's last name from CoBuilder. Yeah, he was in the the General Assembly meeting in Paris a couple weeks ago, and not on that particular one. And there's two ways to handle this. One is those products become components of this generic ID, or actually we logically separate out a generic concept from a product concept, and you make a relationship between them to say this product describes this generic, and we don't try to force like those in this map. They would both be two separate entities, but we use a relationship to make the connection. So we have not gone far to say, you know, try to force GS1 or try to like have this conversation at that level yet. But there's multiple ways of solving it because we don't have this big monolith. We can make point-to-point relationships at the component level or at the entity level. In the back
I'm
there.
not sure if that would be that the governments simply were excluded from the design, but who would be the owner of the from these different stakeholders? And is it like being seen at this moment if there is an entity that I cannot see somewhere in the middle because I do not have the right rights, so I'm not creating a component that is having a big overlap?
I mean, I think the answer is this is a business decision, right? What components need to be shared, what don't. There's a governance component too within buildingSMART, but like ownership of the instance data, we don't want to touch that, and that it's not our place to touch it. You know, if you have a contract that says you must share all components, there you go. If you have if you have internal business logic components and data that are shared components, those are choices. The point is flexibility and choice, not, you know, buildingSMART is not in the, this is how you run a building project or infrastructure project. So let's talk about relationships a little bit. So really this is a component as a relationship. So we've said a little bit in the conversations that everything is a component in this sort of system because it still has the same header. Like a component is not dumb. It actually wants to be more intelligent. It wants to be just as intelligent as every other component. What we haven't really addressed is if certain relationships only exist between versions of components versus the whole component. That's not articulated here. But one of the things you'll notice is a lot of the relationships in IFC are hard-coded. But we definitely see a place where there are all kinds of other relationships that are more robust that have to be, one, it should be easy to make them, easier to standardize them if they need to be standardized, but they should be, allow for more expression than we have today. We have the right amount of relationships to make IFC logical for a building and some infrastructure domains, but like the one, just as an example, Angel, help me if I get this wrong. We have like a wall ceiling sort of relationship. And then actually the technical details of that is the wall geometry is cut by a plane that is not the ceiling. It's just a separate plane. So the suggestion was actually we probably need two relationships. One is there's a logical relationship, and then there's a one bool's other relationship. That would make a lot of sense from a sort of being able to describe things more thoroughly. Whether those are the right relationships we define, standardize, that's a different question. But we think that level of expressiveness it's actually one of the most robust parts of IFC that we never allow for, we don't really allow for expansion. But if it's a logical sort of user-friendly kind of relationship, it should be something that we support. I'll skip over these just to go through some time here. So this is where we know we need relationships. So two let's call them object entities, one relationship. What's missing here, and when you talk through this more, we're going to end up with entity-to-entity relationships, component-to-entity, and component-to-component relationships. Like that example of the Boolean, that's a component geometry relationship, two components together. But the floor ceiling is an entity-to-entity. Wall ceiling is an entity-to-entity. The one that actually is a relationship between two components on the same object, that's very much the idea that some data is derived by data that is a predecessor to it. So source destination logic comes into play. So if you need to build systems, there was one example you mentioned on geometry in Paris. You're not going to remember this, but yeah, but two pieces of geometry, one derives the other, or one simplification of the other. All these things are sort of logical constructs as relationships. What's that? Yeah, slab edge on a slab. Yeah, sorry, I shouldn't have asked. I wasn't going to remember it. So this is an example of when going this around, we're putting this in front of other groups of people that aren't traditionally in the buildingSMART community, because one of the reasons you do this is to actually solve business problems versus just making a new standard, because it's a lot of work. So this is an example of talking through how you might look at carbon with two data sources and carbon as being the third. Okay, so this is an example of the facade coming out of one tool. So on the left we have, I have to read off my screen, the green are material components, the bottom are geometry components, the blue are geometry components. The relationship is type of, and the only thing on the entities on the right are locations. This is the most optimal building in the world. You don't have instance modifications of geometry. It's idealized. But this is a typed relationship, right? The locations are all the individual locations, but everything else can be standardized on a type. So if you look at this bottom one, which is the sort of meant to be the superstructure, we still have green as material columns, concrete, and then we have the geometry at the bottom. But actually in this one we have same kind of thing, but we have more components on the sort of unique instances, because this geometry tends to be more unique. I'm not saying this is the right way to do it, but it's to point to the flexibility of this approach, is the components can be either side of this, and with a relationship you say where you get the definition from. Does that make sense? So we play this forward. I said this was in the context of a carbon demo. Without having or modifying the existing data, you can make new material entities that hold, aluminum, concrete, and the bottom two components are their carbon information. So this is doable today, but really one of the most important parts of a system like this is allows out of order operation, which is sort of a very important concept of adopting a system like this. We showed a little bit of that if I share a little data about the furniture with the contractor, they can add data and I can come back and make updates. This is to say, well, what if I had a library concept of my materials with carbon data, and I had this is where the pipeline system sort of discussion come into play. Again, support of, not making. You watch for entities that are the material I care about, and then automate the creation of these new relationships. Well, what have I done? I've allowed define one bit of logic. If this bit of data shows up, I can associate them together, and I have a 2 + 2 = 3 sort of, or 1 + 1 = 3 relationship, not 2. So if you play that forward a little bit, and you do something more robust, which is to put, well, I want to evaluate early on as much as possible ranges of carbon. I can have mini component definitions that say high, medium, low carbon, and I can make that association. Again, the point is flexibility, and this out of order concept is a pretty important one. Questions on this? I see nods, which is good. Hope, just adding carbon to the presentation didn't get the nods, but Mike?
There is an old question. For example, you're developing families in Revit for someone, and then he said, okay, can you send me an IFC file? And
you can have the geometry already complete.
Yeah, so would this concept help in this? Because essentially what people used to do, they created a single instance of each of the elements and sent the IFC file of those elements, which does not make sense.
Okay, so let's say you're a manufacturer of a fixed, like a chair. Chairs are good examples because they're stable. There's definitions. The Revit, ArchiCAD, whatever tool, they actually are just referencing that geometry. You've already made it. So you can have the manufactured defined LOD 1, 2, 3. It gets referenced in, and at the end, you get the same geometry because you actually can connect. You can make it before, reference it, and then add it back at the end, or you never even have to add it back in. So from a product manufacturer standpoint that are making fixed products, this is where you'd absolutely point to, well, we could support step representations coming from those manufacturers, and we just go around the tools that say where they are. It's not, again, these are supported workflows, not things that we're just building tools for, but these are very logical approaches to these sort of things that you don't have to, if I have a definition, I shouldn't make it again.
Question linking to this components linkage. So you have existing components somewhere. Now I want to enrich it by referencing to the new component. So what are those reference points, or what are the commonalities allow the existing component to link to the new component, which could be private? Nothing.
With the only thing you would need is an entity ID, right? And this is why we think the informational component is like maybe the right way to, the minimum component to make. So I don't have any geometry, I don't have any properties, but I know it's an entity, and I know it's my friend's chair, right? With that, I could make a relationship because I have the entity ID. There's might be tons of data that I don't know about, but I have the entity ID and I have a component. I can make a relationship to the entity, and if I ever get new data, I can add it to it. Or let's say I'm a consultant and there's 2 consultants and 1 owner. The owner can combine them, and I never have to see, none of the consultants see either side. So you do need to share a minimal amount of data to make these connections. Well, at the end of the day, like the idea of an ID component is to say you could do a classification, but you don't there's some minimum you can share, but you have to share something. Yep.
I'm not sure whether maybe this is the right time to ask, but you were saying, well, you just made an example of an option appraisal situation where you were thinking low carbon, high carbon, multiple alternative projects. And this reminds me of something Google tried a few years back, like Google Wave. Maybe you remember.
Yeah, I'm that old, yes.
Yeah.
It's not a few years.
And it was scary at some point to think, okay, how? Because you keep all the deltas, you keep all the versioning and so on and so forth. At some point, technically, we might have to simplify the data structure and kind of inject a snapshot at a given time from which we start again. Is this something that is thought of in the protocol? I'm not sure if the question is clear.
No, it makes sense. So one of the things that we should plan for, and this is something we talked about today, is like this is the most descriptive definition of the data and broken these little pieces. But that doesn't mean that when you sort of decide, I want to send this chunk of data, it couldn't be flattened, right? Because the only reason that makes sense is if we're doing a reference only workflow, the flattened version of this data that's like a flat table structure that sort of brings back in sort of inverse relationships and all these other things, that could be thought of as this section we'll get into is like a version of a collection, right? So I don't think we should rule that out. We haven't done a whole lot. I mean, in my own experimentation, I've looked like Parquet files as a perfect example of how you could make this into a sort of a very fast sort of file-like database. But these are things we think we need to support flexibly. But I think that if you agree on immutability, then a simplification of the data structure is actually just fine. But the second you say, I want to mutate things, and then I want to be able to get them back in the same form, that's when it gets a little harder to do what you're describing. Well, and it's easy to make a very fast readable data source if you're never changing it, right? But let's talk about this. So why do we need to replace the file? I think everybody understands that not all our data fits on any project fits in one file. So we need to be able to put these different together. The first set of terms we used were like assembly and scene. It's not valid anymore, but the data collected shown on the bottom should be able to be represented in multiple ways, not just one. So no component belongs to any collection. A collection is, if you're familiar with in a Git, it would be like a branch. The branch points to the IDs or the hashes of the data set, but it doesn't own the thing. Like in a Git environment, the project owns them. So the same thing would be true here. These are really just, they point to the components, they don't store them. So this is where you'd collect up all the components and their versions to say, this chunk of data that I control, I want to provide to you. And it really wants to at least describe the functionality of how you'd say it's actually for one-time purposes. It allows for updating, or it creates an API endpoint. Because this is you certainly could say make a wall API endpoint, or you could say, well, actually we're a transaction-based world, so I'll make a collection of data, and that's actually how you make an API endpoint for the data. It's not set in stone, but it's certainly something that makes sense. I'll skip over scene. Scene is really just a collection of collections. I don't think we actually need it formally. It was just, nested collections. The thing that, if you are aware of the USD does that we don't want to do, because we want to be more precise about our data, in that world, you can override stuff at these levels above. Oh, I want to make this thing pink, the top level. Not in our world. If you're the publisher of data, you own its appearance. The only thing you should be able to do above here is express it or not. Location is shown or not. Not I can make a new location. That is outside of these things, whereas in the USD world, you could do that. So if you're familiar with that world, that's the case. We have 20 minutes left, so I want to just get to this one has a lot of animations. Okay. So when we actually put IFC as it is today in a system like this, what gets, if you were to make a line between what stays in Express longer versus what doesn't, things that get removed quickly: relationships, grouping, properties, and classification. Geometry is the one that will take time if we ever want to move away from an Express step representation. So does this actually make sense? I made these slides this morning, and these are the ones I'm having to remember the least. Okay, so the first one is really around classification. So the big move we're saying is actually, like in IFC today, we have IFC entities, IFC entity types. Those become classifications. because we'll show an example from Oslo that Angel is very good at pointing out. But we have to make the distinction because you can use the same kind of component in many places. That a component is the kind of data. I'm a faceted B-rep. I'm this property set. Classification says I'm a wall. Those two things are not the same in the system. They're intentionally separate. A faceted B-rep can be used for anything. You can call it a wall. That makes sense? So this is the very good example. Are these, I said roof or wall? What did I say? But yeah, but they're ramps as well, right? So which one are they? So let's walk through this. So first thing we do is we have the entity. We might have the ID component. I'm the first one for any one of these ramps individually. My geometry is IFC faceted B-rep. I have a pset fire rating property, and I have, these are the components, and they're the data sets, not the things, right? It's clear we don't actually know what this is yet. Nothing here tells me that this is a sloped wall, a roof, a ramp, nothing, right? It's just some information. So then the most logical suggestion is you solve this by multiple classifications until you need a new classification. And so the most logical direction, and there's some good discussion to be had about, would I want to be able to ask this question here? That could be an implementation question. It could be we don't need to design classification into every component. We just have classification components. This is something to discuss, but this is a sort of a direction this goes. Questions?
Sorry, I had to take up again. From a game development perspective, now we are kind of having a lot of those way of making our games and the way of describing things, like the USD is a universal seed description. How do you think about different industries mixing up together in this format? Because we have different way of describing things and different way of looking at things. I mean, from a game development perspective, but by the way, I'm from the building of myself, but in my spare time, I like game development. I would think for a car, and you're giving that entities or functions, and I kind of feel when I look at this presentation, I have two different worlds I have to combine. So how do you format it so you don't talk between each other?
Well, there's two ways to look into the problem, and I think it intentionally tries to solve it both ways. One is they don't have to intersect, but the system allows for them to never see each other intentionally. It's one. It's less ideal, but it's a way of solving this problem. But the other is we actually do the inverse and say, well, actually, this is the right way to make relationships between our data, and we coordinate them. Tomorrow in the afternoon, we're doing an OGC session that we're going to prototype some of this in the future. We haven't picked what OGC standard we're going to talk about because it's sort of a voluminous GIS BIM conversation. But clearly, we need to pick some representation on that side and then the one on the buildingSMART side and put them together. But that's going to have to be a collaboration. The key thing is, though, just like you can have your own private components, people could have components in other systems that buildingSMART never knows about.
And things becoming clear.
That's good. There's a lot of slides.
Okay. Yes, I mean, these components, I think in theory, it enables you actually to include more richness about the data representing across different sectors. But
yeah, I mean, you can have the richness of a multi-sector representation.
Exactly. So I'm thinking, because putting that into the picture, the scenario becomes more dynamic. So I'm thinking these components seem to be more transit. So when you do one scenario, you pull data sets by using that UID, user ID from different resources, do the function, analyze it, release it, and then you keep the data privacy from the different companies.
Yeah, so are you describing, like, I don't know, often people might say that, like, this simulation might fall into this category. Two components, bring them together,
Yeah.
simulate to make a third component. That third component is useful, but I throw it away. It's derived from these two, right?
One step of the decision chain.
Yeah.
So I think that components can make that happen.
Yeah, I mean, just to be clear, we've been thinking about this a long time. So all this stuff, like, we haven't obviously thought of every use case, but it is a very flexible and aligns itself with a lot of the way people want to work in our industries, but can't. Okay, so, oh, sorry.
I like your presentation of the part of classification.
Oh, there you go.
Sorry?
I was trying to figure out where you were. The light is bright.
Two classification for one entity, one object is fine, but we have a mechanism or some kind of way to figure out the collision. Like I know the roof thing and the floor thing is great, but if we talk about a chair, they can't be IFC furniture and the IFC column at the same time. So this kind of collision, how we figure out in the component system?
Well, so two things. One is, in IFC today, that would be more confusing because you'd automatically arrive with a certain set of properties that are required if you chose one, right? Like if I chose I'm a wall, I get wall stuff. If I chose I'm a roof, I get roof stuff. If I'm a ramp, I get ramp stuff. That's not the case here, right? You choose which components are used, and the classification is, this is what these describe. And so classification in this instance is probably, if your entry point is thinking it's a ramp, ramp gets you there. If your entry point thinks it's a roof, roof gets you there. Only if you need a much more robust sort of, there's an implication that a slamp, a sloped roof or sloof.
Well, and I was going to add, I mean, in Jeff's lovely hometown, there's an owl statue that is also a bench, right? So that is, if that owl were a column, we have a chair and a column, right? So there's nothing that prevents a column from having a bench on it, right? So you might be able to think of some examples where, no, this absolutely can't be, it can't be a bridge and a floor. It can't. But the point is, I think that's beyond our scope.
Yeah.
I don't think we need to worry about that. I think whatever softwares you're using should point out why are you doing this double classification.
Yeah, and like I said, the classification becomes descriptive of the thing. It doesn't imply what data comes with it. Okay, so next is, we think we should embrace a more simplified representation for a mesh representation. So basically, go back here. What we're proposing is that a GLTF representation is a first-class citizen here. Yeah, I mean, this is so easy. It gives us what it looks like much better than we have today, but we're certainly not getting rid of simpler triangulated methods. There's a discussion to be had of, GLTF is binary, but the triangulated face set is useful. So, but we should look at others as well. We are certainly pointing to IFC as more than a step and express representation of geometry. It's a semantic way of describing the built world. That doesn't mean we have to be limited to a singular geometric representation. This is a nice, easy win for people that want to, I don't know, coordinate and look at their building at the same time, or look at their infrastructure at the same time and know what material it is, these sort of things. Everybody nods. That's simple. Why did I put, and you can do dumb animations in PowerPoint with GLTFs. Let me sort of jump around. I picked that point because, Okay, so let me go back in time. So groupings, I'm using this term generically because if anybody's tried to figure out groupings, any sort of collection of stuff, just because it comes a different kind of relationship. I did this a long time, well, now is almost a year ago. Anybody raise their hand if they're 100% certain what type means in IFC? What information is typical? Properties. I think I'm right in saying that. Not geometry. Certainly, that is the one I'm clear about. I won't try to do this S because I'm quickly going to get over my skis. Map. This is actually for geometry. So now we have 2. Now we have 3 because I want to put them together. If I want to sort of, I can't remember what asset does, but it's a separate kind of group used for interior projects, I think. Then we have inventory, which doesn't have a placement. Then we have element assembly. This one actually allows grouped elements to be placed, but only structural elements. What if I want to add a charger here? All of these are inconsistent and very hard to use. If I wanted to make this collection of things something I place that comes with a piece of charger that isn't part of, you get the idea. So the proposal, oh yeah, Jesus, forgot about this. And then if you want to put it all in a line, you know, it has to be an infrastructure. So really this, oh yeah, this builds itself out. You saw this before. Group of. This is the sort of logic. You can sort of multiple components. I'm showing like these full entity things. You can obviously do component to component groups. Like these pieces of geometry components are part of this analysis group. Thomas.
Yeah. Sorry to interrupt, but I have to correct you. I think the group of is a unique concept, but what you group it to has all this multiple justification you're pointing to. So it's, I see your point.
Groups by. Yeah. I mean, Thomas, you've seen my president enough to know that the words I use sometimes are not the ones you should key on, but or the spellings and so forth. The other one is, oh, sorry.
Just one thing. Why this concept of groups, which is excellent?
No, I don't. You can. You can use a relationship to bridge property sets across objects.
Just is it why it's not a natural behavior that we can dynamically change property sets for certain purposes?
You mean basically
hard coded. In the rest, we have huge flexibility. Here, we have something very hard coded.
Oh no, they're not hard coded. But so we would. I mean, this is not something I have not said. Property sets right now are hard coded to entity types. We would get away from that. Yeah, some number of them are. Yeah, no, that would be a modernization. Yeah, because the like fire rating does apply to certain things, right? Okay, so the most complex.
I really agree with this concept of these groupings, but one thing I'm not clear yet is the thing with mapped items, which is the concept which was involved with CAT to save data amount.
Yeah.
So that you don't have to store the geometry of this chair thousands of times in the building. If you
wait, so actually, this is what's represented in this type. Again, the names you should like throw away. What's on the left is it's not visible in this slide though. So let me just go back to the original place I showed it, because it's intentionally shown there. Oh, it's in black text. That's why it didn't make any sense. In unlegible text on the left, it says types. Here, I'll just change it so you can see it actually. I don't know why it's black, frankly. It's not me trying to hide things. So what's supposed to be represented is like from the top bit of data, the geometry is in the quote unquote type object. Words become really hard here because that's not a really type. It's the typical, right? So the geometry is on the typical, and the instance really just has the location. And then the bottom, because they're less typical, the geometry is on the right. More geometry is on the right. So absolutely, this has to solve this map concept. Yeah, thank you for that. So last one we'll get to touch on today, which is probably that will probably get a lot of people started, is so when you start to put multiple data sets together that aren't aware of each other, you have to move location outside of the data sets. Or not you have to add an additional kind of location external to the data sets. Like the simplest example is something like this. If those two, and I'm using the word file here in the thing that is the big collection of what looks like a file today. If we were to take two existing IFC 4.3 files, put them into the system, and I want to relate them together, I need a external way to relate them together, right? Well, this is not georeferencing. This is just I share an origin that I don't have an internal reference to. So there is and I was delightfully informed that we're using the well-known text approach in 4.3 to do georeferencing, but I don't know. I'm not certain it covers sort of horizontal, vertical transformations and offsets and these sort of things. Because then you have, okay, I have things like I'm saying step, and I mean a step physical file that's not IFC, and I want to sort of do what we said before, like a product manufacturer gives them some data. I want to put this next to historically IFC data. I need to do the same thing. There's the internal location and placement, and then there's the sort of larger world. So you need to start thinking about this. We have a lot of opportunities to go crazy and support a lot of stuff. We should try to keep it simple as possible, but clearly there's very good examples of how to do this in many places. Game engines do it all the time. There's so many examples in CAD systems that this is a well-known problem. We just have to know it's a problem we have. And actually, I think this is something ODA wanted a long time ago anyway.
So we only got a couple more.
Yep. So, yeah. No, I just point out all kinds of other examples we could have on placements. That is it.
Quickly, what's your gut about compatibility with ESDD and IDS? Have you thought about it? Do you think it worked? Do you think these are applicable constructs for this? I think they are.
Well, so I think I'm really not the one that did the work to point out sorry, we got to go way back. On the BSDD side, I think if you think about it, what's exposed in BSDD now is property sets as endpoints, not the properties themselves as endpoints. Correct. Yeah, not the instance data. Yes, the definitions. So certainly we would need to sort of mature this. One of the things that we'll talk about tomorrow is we're going to rip apart that simple structure, like building structure, and sort of map this and show the sort of the actual sort of example schemas we're developing. We need a more robust component definition approach, which is why we're pointing to JSON LD, because it has this XSD XPath stuff that we can be very specific in the definition side of things. This is sort of, I think, where we're going to point to. There was a question in the back. And sorry, did Dennis ask you a question? Yeah, because a requirement can be a component in the system. So an IDS can be have a relationship with the walls it needs to be checked about, or a BCF issue can be a component with a relation to things.
I was wondering whether or not IDS would work as an overall sort of validation on instance assemblies.
Yeah, probably not out of the box.
So we need to wrap this up. Is there a forum or way people can continue to interact in the conversation beyond?
We have a team site, but basically, we're just in the process of formalizing a working group on this, so nothing yet.
Okay, so want to know more? Stay tuned.
Well, and anybody can email me. I mean, you'll have my email address. So,
if there's any other questions, please feel free to find Greg later, either in this break or later on today. You're around tomorrow as well?
Yeah, I'm here Thursday. Yep.
Okay, cool. So I'd like to thank everyone. Hey, Greg. That concludes our session.